in this topic, what we are going to discuss is motion in a vertical circle. This can be considered as a special case of circular motion, or else it can be considered as conservation of energy, or even this can be approached in such a way that actually you are considering the equations of motion. Not exactly equations of motion. Ideally speaking, I should go for conservation of mechanical energy over here. So what we're trying to do is, we're trying to obtain the expressions for tension and velocity of a particle moving around in a vertical circle. And once we are deriving that, we will just find out the minimum velocity at the lowest point so that the particle can complete the loop, and also minimum velocity at the top. So that's what we are going to do. So I have already drawn a figure for a particle moving around in a vertical circle. So when it is at the lowermost point, the velocity we are considering as u. And we are considering a point P after a certain time. In this time, actually, the angle that is covered by this, we are considering as theta. So first of all, we are trying to get the general expression for velocity at any point. So when I'm considering at the point L, at L when you're considering, this is the lowest point. So I can consider the potential energy 0. So U is equal to 0 and K is equal to half mu square you can consider. Now as it moves up and reaches the point P, the vertical height we are denoting as h. And the velocity at that point we are denoting as v. So when we are considering at the point P, it has potential energy and kinetic energy. So we can consider kinetic energy plus potential energy at the point L will be equal to the kinetic energy plus potential energy at the point P. That is, we are considering the conservation of mechanical energy. So this I'm writing, that is equal to half mu square. As I told you, potential energy is 0, only kinetic energy is equal to half mv square plus mgh. So this vertical height, that is the distance between L to M, or otherwise from the ground towards the point P, the height is taken as h. So this we can solve for v as equal to, m will get cancelled. V can be written as equal to u square minus 2gh, and root of that is under root of u square minus 2gh. V is equal to, not v square, v is equal to root of u square minus 2gh. This equation gives the velocity of the particle at any point. That can be the general expression. Okay, so this is the velocity. So first we will write, first what we are deriving is velocity at any point. That is what we have derived first. Velocity at any point. Now I'm going to find the tension at any point, tension on the string. So what we are considering, you can consider an object tied to a string and you're rotating it round in a vertical circle. So it's a tension that is maintaining the particle to move in the circular path. Or else you can tell that there's a centripetal force acting over here. Okay. So by considering the concept of centripetal force, as well as the forces acting along the line, we will just find the value of tension. So let me just find tension at any point. Now, consider the particle at the point P. Think which are the different forces acting over here. Anyway, the weight of the object will be acting downward and tension will be acting towards the center, is it not? So, the component of mg along the radial direction, not exactly radial, opposite to the radial direction, we can tell that it is mg cos theta. So here you can tell T and the centripetal force, that is T plus mv squared by r, is acting towards the center and mg cos theta is acting opposite to that direction. So I can write mv squared by r is equal to, actually it will become T plus mv squared by r is equal to mg cos theta. So I can write T minus mg cos theta is providing the centripetal force. So solving this equation, we can write T is equal to mg cos theta plus mv squared by r. Now, from the figure, when you're looking, what is cos theta over here? We can take the triangle ONP. So in triangle ONP, we can write cos theta. Cos is adjacent by hypotenuse, right? So that can be written as equal to r minus h by r. That is cos theta. So this equation, therefore, we can write that is equal to mg into r minus h by r minus m by r. And I'm also substituting the value of v that we have derived in the previous equation. So you are having v as equal to root of v square minus, not v square, v is equal to root of u square minus 2gh. That means I can write v square as u square minus 2gh. Let me just write u square minus 2gh. We'll just simplify this equation now. First of all, we can see m by r is constant in all the terms. So I'm taking m by r outside. And gr minus gh, m by r already we have taken outside. Gr minus gh. Okay, here this was actually plus. So therefore, plus u square minus 2gh. So we are having gh and 2gh over here. That again we will simplify. That will be m by r into u square plus gr minus 3gh. So we can tell that this is a tension that is acting along the string at any point. Okay, this is a tension acting along the string at any point. Now we will do one thing. We got the general expression for velocity as well as tension. Now we will apply the conditions for the different points. I told you in the beginning. We are going to find the tension at the bottom and the top. We are going to find the minimum velocity that that is needed for the particle to move around in the circular path. So now the special cases we are considering. First, we are taking tension at the bottom. That is at the lowest point. That's a point L. So at the point L, when you're considering h is equal to 0. So you can see that in the previous equation that we have taken, h will be 0. So h is equal to 0. So you can write that equation, that is, but I should name it. Let us put it as equation number 1. And the equation for the tension I'm naming as equation number 2. Let this be equation number 2. So in the equation number 2, I'm putting the value of h as equal to 0. So it will become TL. Let me put it as TL. So TL is equal to m by r into u square plus gr will be there. As I told you, h is equal to 0. That's the reason. Now we will find tension at the highest point. Okay, this is tension at the bottom, what we have done. Now tension at the highest point. So at the highest point, when you're looking, the height becomes equal to 2r. H is equal to 2r. So in the equation number 2, we'll do one thing, we'll copy the equation and then we will put the value. Because I'll have to move up and down like that. Let this be here. Okay. So we have to substitute h as equal to 2r now in this. So we will write TH, that's the tension at the highest point. Over here, h is equal to 2r. So this will become m by r into u square plus gr. H is equal to 2r. So it will become 6gr, right? Minus 6gr. So the gr and minus 6gr we can simplify. So finally what you are having is m by r into u square minus 5gr is the expression that we are having for tension at the highest point. And tension at the lowest point you are having m by r into u square plus gr. Now, let's see what will be TH minus TL. Sorry, we'll go for TL minus TH. TL minus TH. TL is equal to m by r into u square plus gr. That is m by r into u square plus gr minus m by r into u square minus 5gr. So when we simplify this, what we will be having? M by r, u square will get cancelled. So you are having this as equal to m by r into gr plus 5gr. R will get cancelled. And so you are having now 6 mg. So we can tell the difference of the tensions between the lowermost and the uppermost point will be equal to 6 mg. So the difference of tension between the lowermost and the uppermost point will be equal to 6 mg. Okay, need to remember that. And now we are considering what is the minimum velocity that's to be given to the particle so that it can complete the loop. So we are finding right now minimum velocity. Of projection, that is when it's starting the motion from the bottom, this will be the minimum velocity at lowermost point. What you have to think is that if the particle has to complete the loop, when it reaches the topmost point, it should have a tension greater than 0. One of the most important point of the tension in the string is that tension will never slag the string. So here, if it has to complete that circular path, it should be having a tension greater than 0. So the limiting case, you can tell that. So let me just write it. To complete the circular path, TH should be greater than or equal to 0. Remember that tension will never slag the string. That's something to be always remembered. So what was the expression for TH? It is M by R into, well, let me just copy it and take it down. This is a value of this tension we have. So this should be greater than or equal to 0. So if it has to be greater than or equal to 0, then you can tell that U square should be greater than or equal to 5GR. Or else you can tell U should be greater than or equal to root of 5GR. That is the minimum velocity required to be given if the particle has to complete the loop. So we can tell root 5GR is the minimum velocity required. Minimum velocity required by the particle to complete the loop. To complete the vertical circle, we can write. Complete the vertical circle. Now we will find out what will be the minimum velocity at the top. So next what we are trying is minimum velocity at top. This now we can just apply the either, as I told you in the beginning, conservation of energy or else even equations of motion we can consider. So here I am going for v square minus u square basic concept, or else the change of energy also, as I told you. That is, here when it goes from bottom to the top, at the bottom it has only kinetic energy, and as it is going over there, it is moving to a height equal to 2r. At that point, it will be having kinetic energy as well as potential energy. So at that point, we can consider half mv square plus mgh. H will be equal to 2r. This is the total energy at the top. Will be equal to half mu square. Will get cancelled, and you can tell v square is equal to u square minus 2g into 2r, right? 2g into 2r. Just note down here, h is equal to 2r. That is the reason that's coming. And now we have derived the equation for u square. That's the velocity, the minimum velocity at the bottom, that we were having as equal to root 5gr, right? So in the place of that, we will put 5gr minus 4gr. That will come out to be equal to gr. Or else you can tell the velocity at the top will be equal to root gr. This root gr, this is also called as the velocity at the top. This velocity is also called as a critical velocity. Okay, this is called critical velocity at the highest point. Okay, quickly see the different points that we have discussed right now. First of all, what we have done, we are considering the first thing what we have calculated, what will be the velocity at any point. General expressions we were calculating. So when you're considering at the point L, it is having only kinetic energy because that's the lowermost point. And as it moves up, it will be gaining potential energy because it's covering a certain height. Potential energy as well as kinetic energy is there. According to the conservation of the mechanical energy, we are equating those two energies and we have solved for the velocity at any point. Then we consider tension. So in tension, we were considering the different forces acting over here at the point P. And so we have seen T and mg cos theta are the forces. And therefore, the net force acting towards the center will be equal to T minus mg cos theta. And therefore, we said that provides a centripetal force. Solving that, we got the general expression for T. Okay, we'll do one more thing. We'll just put the main equations to be remembered. This is one of the equation that is needed. And now after that, we need this particular equation, general expression for the tension. And then what we have considered is basically the maximum velocity at the bottom, that is the minimum velocity to be given so that the particle can complete the circular loop we have considered. And after that, what we have done is, if it is moving with this minimum velocity, when it is reaching the top, what will be its velocity? That velocity we are also calling as the critical velocity.